This is Paige Baxter. Today I will be annotating our group lesson plans using NGSS Science Standards for Grade 4, Code 4-PS3, Energy.
About how we can make electricity from using batteries and other materials. So we will be showing a video to introduce what we will be learning in this unit, and I hope you guys like it.
Hi, I'm Lee Patrick Sullivan with Energy Now, and today I'd like to talk to you about the power of the sun. Solar power is the most abundant, most renewable resource we have. If we could collect 1/100th of 1% of the sun's energy reaching the earth, it would be more energy than all humans use today. Just outside Yuma, Arizona is the sunniest place in the world. 90% of the year the skies are clear. And these southwest deserts have enough suitable land to supply 80% of the entire planet's current use. The sun has produced energy for billions of years and naturally energizes all of the plants on the planet. These plants give energy to animals and power the human body. This is done by a process called photosynthesis. For decades now, scientists have unlocked the secrets of how a plant creates energy through photosynthesis and can duplicate that process using modern technology and silicone. This process of creating electricity from the sun can power our homes and cities. There are two ways of capturing the power of the sun. First is photovoltaic devices, more commonly known as solar cells. They change sunlight directly into electricity. These individual cells are joined together to make solar panels. These can be placed on rooftops, in calculators, and even on large-scale fields covering many acres to power cities. Solar energy systems produce no air pollutants or carbon dioxide. And because they can be placed on the top of existing buildings, they do not require extra land for power plants. Another way to capture the sun's energy is by capturing its heat. Solar thermal electric power plants generate electricity by concentrating solar energy to boil water, which then produces steam. This steam turns a turbine, which moves a generator to produce electricity. Solar thermal electric plants consist of fields of mirrors to reflect the concentrated sunlight onto a receiver. The receiver then collects the solar energy and converts it to heat. The production of energy from solar thermal plants work essentially the same as fossil fuel power plants. But instead of producing steam from burning fossil fuels, the steam is made by the sun. The only downside to this source of technology is that the power only exists as long as the sun is up. To help solve this problem, other forms of solar technology have been explored. Scientists are currently working on methods to store this energy for cloudy days and nighttime. One way to conquer this problem is building new power plants that combine a multitude of renewable energy sources. Using solar power and wind power and biogas could do this. When one method is not creating electricity, the other could take over. Other methods, such as storing excess power in batteries, could also be a possible future for solar technology.
Alrighty. Hey guys, so I'm going to number you off real quick. You're going to be in groups of 3. We're just going to do that because we're going to do...
Here I hit 4-PS3-B, Conservation of Energy and Energy Transfer. The standard is hit as I ask what the main points of the video were.
What the main points of the video are. And so we just want to see how well you listen to the video. It's only one question. So we're going to take it at the beginning of the lesson, and then we'll take the same survey at the end of the lesson to see if your opinion changed about what the main points of the video were. So we'll go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is the link, so you guys can get on. You can just have one computer to record your group. What up? Where are we going? Where are we going? You're 1.
1, 2, 3, and 3.
You can just take it as a group, so just one computer per group is totally fine.
Who's 2?
You're in 3 groups. So we have, is this ones? Yes. And this is twos, and then 3s are back here congregating? Perfect. Alrighty guys, so we'll give you like 2 minutes for one question, so it should be pretty easy.
Where the main points, you can capture energy by using solar panels. Solar energy is important and can be utilized in many ways to help with conservation and energy, so they spell conservation wrong. And storing energy is a huge step. This is like the central. Yes, they belong to. Yeah.
Alright, are we done? Everyone done? No? Okay, it's okay. Take a couple minutes. It's fine.
Typing in the address takes a long.
I know.
So I was group 1. How are you? Sick. My roommate was sick. Tuesday night when I was gone. She got super sick.
We're good? Okay guys, so now we're have a little PowerPoint presentation. It's basically just gonna go over the main points of the video, and then we have a super awesome activity. Alright, so as far as the video goes, the main points were the power of the sun is the most renewable resource we have. The sun provides plant growth through photosynthesis, which provides animal and human growth. You guys saw that in the video. Showed the process of
As we continue the presentation, you observe me hitting standards 4-PS3A, definitions of energy, PS3D, energy and chemical processes in everyday life, and finally benchmark ETS1.A, defining engineering problems. All of this is demonstrated through me going through the PowerPoint slides and the presentation and going over transfer of energy, advantages of solar energy and disadvantages of solar energy, etc.
Solar heat can be concentrated and used to generate electricity. So some advantages of solar energy are it creates no air pollution, so there's no CO2 in the air, which is super cool. It can be placed on the top of the buildings, thus a smaller footprint. And so basically what we mean by a smaller footprint is that we're not going to have to make new space for this new energy. It's not going to take up a bunch of space, so that's convenient. And it does not use fossil fuels that require the mining of minerals. Some disadvantages is obviously the sun isn't always available because we have nighttime when the sun goes away and goes to sleep. And then we need better ways to store the produced energy, and we don't have those ways on demand. We talked about that in the video as well, that they're trying to think of new ways in order to store this energy. And a large scale needs a larger footprint. So going back to, we described what a smaller footprint is. Who can tell me what a large footprint would be, or what you describe one as? Just
Like
now.
a windmill, so you're not going to beach field.
Perfect. So just taking up more space. Alright, so now we are going to go over to the activity. Russ has some super cool stuff planned for you. And so if we want to get into groups of...
Well, groups of 3, just break your groups.
Just
in
break
half.
your groups in half.
Yeah, 2
So
or 3. Again, we should
2 or 3 people
should
per
have done
group.
with about 6.
Let's go and then you guys. Yeah, all right, we're just right there. Oh, you guys are millers. I'm just kidding.
Yeah.
Can everybody see if I work right here?
Yeah.
Okay, I just want to get as close as possible. So get where you can see, please. And what we've got here is this little physics workshop. And it's my son's, and so I borrowed it from him, but asked him to build me something, and he said, okay, what? I said, I don't care, build me a car, I don't care, whatever. So he built me this little elevator, and what I'm going to use here is a battery, which is chemical energy, and we're going to convert that energy into mechanical energy and raise this little elevator up its shaft. And then I'm also going to demonstrate...
Here, you see my group member Russ hitting standard 4-PS3-2. Make observations to provide evidence that energy can be transferred from place to place by sound, light, heat, and electric currents. Russ demonstrates all of these throughout his presentation.
And you would use... How would you use these in a different way on a larger scale? Think big. We talked about the big field of them. Footprint. Yeah, you can power things, right? And you can get that from the sun. So I'm going to use a simulated sun right here. Hopefully it reaches. Yeah, it does. Hey, look at that. Okay, so shield your eyes if you're sensitive to bright lights. And ironically, I am using, this is actually an LED light because I thought I'd try to convert the energy most efficiently as possible. although we couldn't ever use 100% of that. So you can see when I turn the light on, it actually works. It works. We all witnessed. There you go. Sometimes you have to kind of give a little bit of a jump start. So now we've converted light energy to mechanical energy. We've converted chemical energy into mechanical energy. What about converting mechanical energy into light energy? What I've got here is an LED. I wouldn't be able to power one quite that big without getting a bigger motor. But there's a little motor there, and so what we're going to do is we're going to convert that to light energy. And with an LED, just so you know, the current has to go in one specific direction. So if it doesn't work one way, you just turn it around and it'll work the other way. Now I could turn around. I'm just going to turn the motor in the opposite direction. And can everybody see that that's lighting up as I turn it? So there we go. We've converted energy from 3 different forms to another form, from, like I said before, solar energy to mechanical energy, chemical energy to mechanical, and then mechanical energy to light. And what you guys are going to do is each of you has a kit, and not all of them are the same. Some of them are going to be converting from solar to another form.
I don't know if this is right.
Oh yeah, this one's.
Some of them will be converting from a battery to another
I
form.
think you're right.
So what you want to do is use the
As soon as you do it right.
2 leads with the alligator clips on each one, and you should be able to make sure you're touching the bare wire on that. And somebody has one that makes sound, actually. And then once you think you've got it ready, come up and we will test it out.
And sometimes you have to like give a little kickstart. Yep, see? How cool is that?
Because those
Yeah,
aren't
you
bright
show me
enough. You gotta be really close. Did you notice how close I was with that light?
Oh yeah, awesome. You guys are on top of it.
Way to go, guys.
It's like
Marcus, you look very proud of yourself. I used to have kids like this when I was a little kid. Good job.
they're awesome.
What's that?
All right, which one do you guys have?
Better make sure they're not touching. But yeah, you just hook these up to that.
So pretty much
That's
you
going
want
to
to
make
set it
sound.
like one way and work it a different way. So just flip it around.
How young were you to start using it?
Hey, look at that.
No, really, it's working. Just
Exactly.
Here, Russell, you turn.
it's working.
Yeah.
See, watch.
I was thinking of starting my
Told you.
Okay, what's up?
It's
And once you turn it, bring it,
under the
you gotta
lamp.
bring it over to the
Okay.
light. You guys hear that? Can everybody hear that over back there? Yeah, that's converting light energy to sound.
Which is so
Wow.
cool. It's like a
That's
dog.
what we're thinking, that like with our lights, if we figured out a way to, you could put like solar panels, if you had all LED lights, you could put solar panels like on the top of your computer. If they were close enough, you could run your computer off of the lights in your room. Would that be possible?
That would be stretching it. That would be stretching. They'd have to be pretty close. Notice how close we have to get with that. And they aren't just going off right now, like just sitting there.
So is there any way that we could use the LED that we're, like the light from the LED lights that we're getting right now to make any sort of energy from that? Like reuse it as it's.
Well, these aren't LEDs. These
I know,
are, okay.
these ones, but
Okay.
like,
Could we use the light that's coming off the LEDs that you are hooking up
maybe
now?
not those teeny ones, but like that on a larger scale.
Well, when you convert energy from one form to another, you're going to have a loss, usually in heat. Like a light bulb, a regular incandescent light bulb that you would just plug in, loses a lot to heat. A lot of that energy is converted to light, but most of it is converted to heat. And that's why when you touch it, it's so hot. And in fact, these, they use a lot less energy, but they're still pretty hot. If you were to reach up and grab one, and I don't know if it'd burn you, but you'd say, wow, that's really hot.
So did everyone get their kits going properly? Obviously you did, Marcus. You're really cool over there with your little wheel. So everyone got everything to work properly. Does anyone have any questions about